Hi everyone, hope you're having a good day today. So today we're going to be going over question 6 in Bluebook Test 1, Math Module 1, which is about reading charts and using that to find values and probabilities. So we'll start with number 6 and then we'll do 3 follow-ups. Okay, so the table summarizes the distribution of color and shape for 100 tiles of equal area. So then there's the table. If one of these tiles is selected at random, what is the probability of selecting a red tile? So it says red tile, there's 100 total, which is nice. We don't do the math. They tell us that. And then it is saying 10, selecting red tiles, right? There's 30 total of that. So we're going to do 30 out of 100, which is 3 over 10, which is, right, 0.3 or 30%, right? So this is a nice clean one. And it could be more complicated, right? If they ask for square red tiles, we would do 10 out of 100, or pentagon blues, we would do 10 out of 100, or pentagon yellows, 15, right? Or all pentagons, 45, but this is just all reds, and that's 30 out of 100. So this one's really testing just, do you read the question carefully and understand the basics of probability? So we'll try 3 more and see how they go. Okay, so now the next one is here. The table summarizes the distribution of favorite ice cream flavors for 10, 11, and 12-year-olds at a school. If you choose randomly from the group, what is the chance the student prefers chocolate? Okay, so we're choosing for the whole group, right? So we need to find the total. The way you can find the total is find the total of chocolate, find the total of vanilla, and then add them together. So it'll be 50 plus 45 plus 25 for chocolate. That equals 120, right? So that goes here. And then you do the same thing for vanilla. And that'll be 30 plus 40 plus 60 equals 130. And that goes here. And then we can add them together and get 250, right? And if you went down, you could do it like this too, right? And find the totals for 10-year-olds, 80. For 11-year-olds, 85. And then for 12-year-olds, also 85. And that also gets you 250. You just wouldn't want to do 250 here, 250 there, and then double them here and get 500, right? That could be the mistake. So then what is the chance the student prefers chocolate? So chocolate's 120 out of 250. 250, we cross those out, so 12 out of 25. To get that to decimals, you just multiply them both by 4. So 12 times 4 is 48, and our answer is A, 0.48. Okay, great. And now we're going to go to the next one. Again, if you have questions on this or any of them, feel free to let me know. So now we'll start this one here. The table summarizes the distribution of favorite ice cream flavors for 10, 11, and 12-year-olds at a school. Okay, so same beginning sentence. If we choose a 10-year-old randomly from the group, what is the chance the 10-year-old prefers vanilla? So let's look at these numbers, right? This would again be 50 plus 70, which is 120. This is again 100 plus 30, so it's 130, and we have a total of 250. And we're choosing a 10-year-old randomly from the group. What is the chance the 10-year-old prefers vanilla? So there's a total of 80 10-year-olds. And then to get 80, the vanilla would be 30 out of 80, right? Which would be 3 out of 8, which is D. Now, the issue you can have on this one, right, is if you did 30 out of 250, or if you did all 10-year-olds, which would be 80 out of 250, or if you did 30 out of 130, right? But you're choosing from the 10-year-old group, so that's the denominator. And then you do the numerator as the 10-year-olds who prefer vanilla. So it's going to be 30 over 80. Okay. All right, so now we'll go to one last one and we'll be set. All right, so now we're on the last one. The table summarizes the distribution of favorite ice cream flavors for 10, 11, and 12-year-olds at a school. If you choose randomly from the group and the student likes vanilla, what are the odds the student is 11? Okay, so now we're going to the vanilla, right? That's going to be the denominator because we know the student likes vanilla. 30 plus 40 for 60, again, is going to get you 130. So what are the odds the student is 11? So it's 11. So we're going to do 40 out of 130, right? Cancel out the zeros and we get 4 out of 13, right? And I think the ways people could mess up here is doing 85 out of 130. We're doing all 11-year-olds, or doing chocolate somehow, or flipping it and doing, if you're 11, what's the odds of you liking vanilla? But it's saying you do like vanilla. You just want to know the odds of the student being 11. All right, so that's sort of the types of questions you can see here with this, right? There's more complicated versions that we'll go over in the future. If you like this video or have questions, put that in the comments, and please like and subscribe, and I will talk to you all later.